Hey, how's it going, everybody? Welcome back. Today on Milanese Math, we are going to tackle part 3 of our series on the rules of exponents. And as always, if you want to follow along with this worksheet, it'll be the first link in the description below. Okay, so I highly recommend you watch parts 1 and 2 because we are going to assume that you already know how to do those rules of exponents. As a quick refresher, this first problem comes from the very first video that we did. And if we have a problem like that, where we have x to the second power times x to the fifth power, the rule there says keep your base and add your exponents. So we would call that x to the seventh power because 2 plus 5 is 7. Then in the second video, we learned that if you have an exponent to an exponent, like x to the second power to the fifth power, you would keep the base, but in this example, you multiply your exponents. So that's gonna be x to the 10th power. So we covered those two rules, and I'm gonna assume that you already know how to do that. And then let's take a look at a new situation where we kind of glossed over this a little bit in the previous video, but I wanted to slow down and make sure that you understand how this works. So let's say you have a term like xy to the second power. Again, I'm a huge fan of just taking a few minutes here, make a table, and then you'll remember what the shortcut is. You'll remember what the rule is for how to handle these once you see where it comes from. So if I were to expand these, write these kind of like in an expanded form, xy squared is kind of like saying xy times itself twice, xy times xy. Now, if I wanted to, because of the rules of multiplication, I could regroup these. I could put all of my x's together. And in this case, I've got 2 of them. But I also have 2 y's, so I could group them based on what the variable is or what the base is. Okay? Now, I could rewrite that x times x is the same as x squared. And y times y is the same as y squared. So what we're going to be looking for as we fill out this table is how do we go from that first column, the single term xy to the second power, and land at x squared, y squared. So let's do another example. Xy to the third power, well, that would be xy 3 times. Xy, xy, because it's to the third power, so that means multiplying it times itself 3 times. Okay, we could regroup these based on the variables that are there. So if I were to put all of the x's in one group of parentheses, that would be, there's 3 of them, so x times x times x. And then I could do the same with the y's. There's 3 of those, so y times y times y. If I wanted to rewrite those as one term, it would be x to the third power, because there's 3 of them, y to the third power, because there's 3 of them. Okay? We're gonna keep just looking for a pattern as we go. X, y, z to the third power. Okay, if I were to write that, it would be x, y, z, x, y, z, x, y, z. Because it's to the third power, so there's 3 groups. Now I could regroup this. Now I'm gonna have, I guess, 3 groups, right? I'm gonna have the x's, of which there are 3, and then there would be 3 y's. And then altogether, there are 3 z's as well, okay? So if I were to rewrite that as just sort of one term, I would have x to the third, y to the third, z to the third, because there happens to be 3 of each of those, okay? Again, the base can get as complicated as you want. Look at this one, a, b, c, d to the second power. So if it's to the second power, that means it's times itself twice. So it's really a, b, c, d 2 times. Okay. Now, if I were to regroup those, I would have 4 groups because I have 4 different letters. So I would call that a times a, then this would be b times b, c times c, and d times d. Okay. Now you could, again, hopefully you're starting to catch on to a pattern a little bit here. Check that out. It would be a to the second, b to the second, c to the second, d to the second, okay? And again, looking at that first column, the single term, and trying to think of a shortcut or a way that you could get all of these right without having to go through all these middle steps. Let's do one more, and I think it should be pretty apparent. Xy to the fourth power would be 4 groups of xy. So xy, 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 and a 4th one, xy. Okay, I could regroup those. There would be 4 x's, and 4 y's. Great. So how would I rewrite that? Well, that would be x to the fourth power, y to the fourth power. Okay, that was the hard part. And hopefully at this point, you're starting to recognize the pattern. And so it says, what pattern do you notice? Well, just like in videos 1 and 2, the rule is that we're gonna keep the base, whatever the base is, in this case, keep the base. And then there's a bunch of ways you could say this, but like look at the very first one, xy squared, and then it turns into x squared, y squared. So you're gonna keep each part of the base, and then each base gets the exponent. So each base gets the exponent. So we kind of talked about this a little bit in the second video, but I wanted to slow down and make sure that you understand how this works. So let's just run through a few of these. We're going to do a few of these together, and I want to show you how the rules from the previous videos kind of combine with these rules to help us solve some more complex problems. So not all of these are going to use that rule. In fact, number 1 looks like some of the video from video number 1, some of that very first rule that says keep the base and add the exponents. So y squared times y to the 8th, you keep the base and you add the exponents. So far, didn't really require us to apply this rule. How about number 2? How would we handle that? Well, that's a lot like the last video that told us to keep the base, multiply the exponents, because we have a power to a power. So 4 times 3 is 12. Now, finally, here in number 3, we can use this rule that says keep the base and then each base gets the exponent. And I'm drawing those arrows that makes it kind of look like the distributive property. It is not the distributive property, but those arrows kind of help us remember that each one of those is going to get the exponent. So it would be h to the 7th, j to the 7th. Okay? Now, the reason we're going slowly with this is because sometimes you have to apply multiple rules in the same problem. For example, c d to the 5th power, then that whole thing is to the 2nd power. So if we look at our rule from today, I would say that the c is going to get that exponent of 2, and so is the d to the 5th. So you could simplify this and kind of rewrite it as, well, c to the 2nd, and then you would maybe say d to the 5th to the 2nd. And that's correct, you're just not finished yet. And the reason you're not finished is because there is another rule that we can apply. The c squared is fine as it is, but if you remember from the previous video, when I have d to the 5th power to the 2nd power, that's a power to a power. And that tells me to keep my base and multiply my exponents. So 5 times 2 is 10. So again, what I always recommend to my students is just take your time with these problems, look to see if you can apply a rule, and then when you're done with that, double check to make sure that there aren't any other rules that are to apply. If there are, then you're not finished and you need to keep going. Number 5 is going to be a pretty good example of that. So take a look at what we've got going on here. N to the 4th power times 2n squared times 2n squared to the 4th. If you remember from our video on order of operations, that's going to tell me that this is going to have to happen first, okay? So it's got exponents, and we got to deliver that to those that whole term. So what I would do is just write these terms below there. I'm not doing anything with the n to the 4th right now, and I'm not doing anything with the 2n squared right now. Hopefully this doesn't blow your mind. You ready? 2n squared to the 4th power would be 16n to the 8th. Again, hopefully I didn't blow your mind too much here. Check that out. Where did the 16 come from? Well, this 4th power goes with the 2. So 2 to the 4th power is 2 times 2 times 2 times 2. That's 16. And then the n to the 8th came from the n squared to the 4th power, which tells me to multiply. So this is why it's really important to have those previous rules on lock in your brain, because you have to apply them in the middle of a problem. Okay, well, this is good, but we're still not finished yet. And I know we're not finished because we've got a few things we can do. As I scan left to right, I see n to the 4th, 2n squared, and 16n to the 8th. We've got some coefficients. Let me take care of those first. So I've got a 2 times a 16. That's 32. And then the rest of this would apply the rule from the first video that we did, which says to keep your base and add your exponents. So n to the 4th, so I've got 4 plus 2 is 6 plus another 8 is 14. So 32 n to the 14th power. None of these rules are super complicated in and of themselves, but they just require you to keep track of what you're doing. Look at number 6. A squared times b times c to the 6th power, and that whole thing to the 3rd power. And then when we're done with that, we got to multiply it times a to the 4th. Okay, this really isn't that bad. If you really start to look at this and realize, okay, each one of these guys is going to get the 3rd power. So if it doesn't blow your mind too much, I'm going to simplify that as a to the 6th, right? Because 2 times 3 is 6. Technically, on this b, it's b to the 1st power. And if it makes you feel better, you can put that exponent of 1. When you don't see an exponent, it's assumed that there's a 1 there. So I'm going to call that b to the 3rd power, because 1 times 3 is 3. And then c to the 18th power, and I got that from the 6 times 3. Now, you're good, except don't forget you've got that a to the 4th power. So what would this simplify to? If I were to take this all the way to the end, I have to combine the a to the 6th and the a to the 4th. That'll be a to the 10th. And then, of course, I still have that b to the 3rd and the c to the 18th power. Okay. We're just going right along. Again, I'm just trying to help you get your brain trained to see these rules in order of how you should apply them. So, for example, if I look at number 7, g to the 5th times g to the 4th to the 4th power, that automatically tells me I want to do that g to the 4th to the 4th and call that g to the 16th, okay? Because we have a power to a power. We still have to deal with that g to the 5th, but I just went ahead and did the g to the 4th to the 4th. Now, hopefully, from that very first set of exponent rules that we talked about, you can see that this is a situation where we will keep our base and just add those exponents. So g to the 21st power. Okay, good job so far. Let's do one more together, and then I'm going to let you try some of these on your own. So we've got 2x to the 4th, y to the 4th, times x to the 3rd, y to the 4th, the whole thing squared. Good gracious. Okay, the first thing I'd like to do there, hopefully your brain is already starting to tell you this. If not, the more you practice this, the more it'll come to you. But I want to take care of this 2nd power and give him out to both of those terms before we do anything else. So this 2x to the 4th, y to the 4th, he's just going to stay exactly like he is. How would I simplify that? What would x to the 3rd to the 2nd power be? Well, I would call that x to the 6th, because 3 times 2 is 6. Similarly, this is going to be y to the 8th power, and that came from 4 times 2. Now, all we have to do is multiply our coefficients. Technically, there's a 1 out in front of this. I don't know if that matters to you, but I would call that 2 times 1, so that would just going to be a 2. And then, let's see, I'm going to call this x to the 10th power, because I had 4 x's out of that first group, 6 x's out of the second. 4 and 6 makes 10. And then y to the 12th, because there was an exponent of 4 and an exponent of 8. In that situation, you can just add them. So again, guys, none of this is overly complicated by itself. The thing that kind of makes your brain hurt a little bit is when you're trying to apply more than one rule in a given problem. And that's why we're slowing down and just taking these one at a time. So right there, I would go ahead and pause, try the rest of these on your own. I hope this video was helpful, and if it was, consider subscribing to the channel. And as always, thanks for watching, and we'll catch you next time.